Greetings, young mathematicians. Welcome to Saxon Math, Lesson 99, the Pythagorean Theorem. Alright, starting with our mental math, which you have already done. So looking at a positive and negative, and oh my goodness, these are starting to look quite simple. I can just look at this and think, well, it's sort of like 45 minus 15 would be 30. So I can just look at this and say 1.5 subtracted from 4 and 5/10 would just be 3. Order of operation and exponents. So 8 times 4 is 32. Times, then we have 10, and that would be to the power of 10. And they don't tell us to put it in scientific notation, but boy, sure is simple just to add one exponent, and then we can just put this in scientific notation by putting our decimal point there. So we got 3 2/10 times 10 to the 11th power. And ratios. Well, this is kind of fun because looking at this, well, we have our 15 in on one side. But looking at these, well, I can just look at this and say, well, 3 times 5, bring one of these boinky, and well, I just end up with 15/100 times n equals 15/100, making n equal 1. All right, converting negative 15 degrees Celsius to Fahrenheit. Well, we would start out by multiplying by 1.8. And spoilers, that will get us negative 27. Plus our 32 will get us 5 degrees Fahrenheit. Calculation! Well, 12 times 2 is 24. 1/3 of 12 is 4. So that'll get us 28. Percent. Well, 33 1/3% is just 1/3. So 1/3 less than 60. Well, 1/3 of 60 is 20. So 20 minus 60 will get us $40. Geometry. What shape has 6 faces and 8 vertices? If you said a rectangular prism, you're right. Rectangular prism for G. Okay, and what is the square root of the sum of 6 squared plus 8 squared? Well, what's the square root of 100? Is 10. All right, let's go take a look at what we're learning today. The Pythagorean Theorem. So the longest side of any right triangle, that is called the hypotenuse. And then the other two sides, we could call those, the legs. So if we are looking at a right triangle and say trying to calculate one of the sides, we can use the rule that the area of the square drawn on the hypotenuse is going to be equal to the sum of the two squares created from the legs. So in this case, if we say that if this side is 3, then the square we get is going to be 9 cubic units, and 4 would end up being 16 cubic units. And yes, that will add up to our 25 over here. So essentially, if you do not have the length of one of the sides, but have the length of the other two, you can figure out the missing information. So let's do this in a few examples. Copy this triangle. Draw a square on each side. Find the area of the square, then find C. Okay. Now, I'm just going to warn you right now that my app's ability to fix my geometrical figures is limited. I think many of our squares are going to end up looking like rectangles at best. And oh, it won't like the squares I try to draw off of the angular hypotenuse either. But that being said, let's dive in. And I failed my first one. Ta-da! Lovely. Okay, so looking at this one, we have 6 centimeters for this leg, 8 centimeters for this leg, and we do not know the value of C. So drawing box on this side. Oh, let's see if I can get one a little bit closer. That's a rectangle. So this one would be 36 centimeters squared. And the bottom one will be 64 centimeters squared. So now we just need to figure out what this other triangle is going to be. Well, this looks a wee bit like the mental math we just did, doesn't it? So what we can do is we can add up the other two squares, getting us 100. So that would make this square is 100 centimeters squared. But what we're trying to figure out here is what is the value of C? Well, all we need to do for that is just get the square root. Getting us C equals 100 centimeters. For this side. All right, here's another example. And So we're just going to figure out the value of A. Okay, so we've got this square. Oh, why don't we make you a different color? Unless that happens. Okay, don't know why it's being so grabby. Sorry, people. Maybe I'll try from this side. Okay, that's, well, fine. Anyway, so looking at these, we can say 12 times 12 is 144. And these are in inches. Inches squared. 13 times 13 is 169 inches squared. So we would just need to add these two up. Oh, no, actually, we do not add these two up. We will need to make an equation because we need to figure out what this guy is. So our equation is actually that A squared plus, either one would work, but we'll just say the plus 144 inches squared equals 169 inches squared. Because 144 plus our A will add up to that. Okay, so we actually just need to subtract from each side. Getting us 25 inches squared for this rectangle, or for this square. And so our 25, our square root of that, will get us A equals 5 inches. Okay, so now we're just finding the perimeter, which is exactly what we've been doing, except we're just adding a step of adding the sides together. I'll try one more time. Very nice. Okay. So we have our 4, are they telling us what you got? Centimeters, and our 3 centimeters. Okay, so looking at these, and sorry if my dimensions here are not perfect, but so here we would have, this would be 16 square centimeters, 4 times 4. This would be 9 square centimeters. So we can add these together. Ooh, and make an orange. So we know that this one is going to be 25 centimeters squared. Because we add these two up to figure out this one. So now that we know that, we can get the square root of 25 to figure out the length of C. So now we know C equals 5 centimeters. And well, now we can just add them all together. 5 plus 4 plus 3 equals, the perimeter equals 12 centimeters. Example 4. Copy this right triangle, then draw squares on the side. Then write an equation that shows the relationship between the areas of the squares. Oh, well, after everything else we've done, this is pretty much child's play. Okay, well, so the area of the square created by leg A is equal to A squared. And the square created by B, by leg B, is equal to side B squared, and the triangle, the square created by our hypotenuse, yeah, I knew that was going to happen sooner or later. We'll try one more. All right, is C squared. So the relationship we can look at is that A squared plus B squared equals C squared. So let's remember that the Pythagorean theorem, it applies to all right triangles. This will always work with a right triangle, but it applies only to right triangles. So, unless you see that it is a right triangle, then this will not work. But if it is a right triangle, then, oh my goodness, what a miracle we have here. Okay, so at this point, you should be sure to do the practice set on page 689 and be ready to check that with me at our afternoon meeting. All right, have a great day. See you.